Welcome to our Godot 4.3 tutorial on procedural generation using cellular automata. In this video, we'll create a 2D cave-like structure using simple ColorRect nodes. It's a powerful method that can add variety and replayability and randomness to your game worlds. The full code we're using today is linked in the description. Let's get started. Open Godot 4.3 and create a new project. Create a new scene with a node 2D as the root. Name it Cave Generator. Attach a new script to the Cave Generator node. Name it cavegenerator.gd. First, we define our constants. These set the dimensions of our cave and the size of each cell. Next, let's create an empty container that we'll use to store our cave data. We'll fill this array with nested arrays, effectively creating a 2D grid. Each cell in this grid will be either true, representing a wall, or false, representing an empty space. To fill the container, let's create the Initialize grid function. This function creates our initial random grid, which serves as the starting point for our cave generation. It uses nested loops to build a 2D array structure. The outer loop runs the number of times defined in our width constant, creating an array for each column. And the inner loop runs the number of times defined in our height constant, filling each row with cell values. Each cell is set to either true, which is a wall, or false, which is an empty space, based on a random chance. The randf generates a random float between 0 and 1, then compares it to 0.45, which results in approximately 45% of cells being walls. Next, we create the generate cave function to apply the cellular automata rules to transform our initial random grid into a cave-like structure. It runs for a fixed number of iterations, 4 in this case, where each iteration refines the cave layout. More iterations generally result in smoother, more defined cave structures. The number of iterations can be adjusted to achieve different effects. In each iteration, it creates a new grid based on the current one, applying these rules to each cell. For wall cells, if a cell has 3 or fewer neighboring walls, it becomes empty. For empty cells, if a cell has more than 4 neighboring walls, it becomes a wall. This mimics natural erosion and formation processes, creating more organic-looking shapes. The count neighboring walls helper function is used to determine the number of walls surrounding each cell. Let's add that function now. This function counts the number of walls in the 8 cells surrounding a given cell. It uses nested loops to check all adjacent cells, including diagonals. The loops run from -1 to 1 in both x and y directions, covering a 3x3 grid centered on the target cell. It skips the center cell as we don't want to count the cell itself. The function handles edge cases by treating out-of-bounds cells as walls. If a neighboring cell would be outside the grid, it's counted as a wall. This creates a border effect, making the edges of the cave more likely to be solid. For inbound cells, it checks the current state of the grid. If the neighboring cell is a wall true in our grid, the count is incremented. Finally, let's create the draw cave function and break it down in more detail. It visualizes our generated cave structure by creating and placing ColorRect nodes for each cell in the grid. It uses nested loops to iterate through every cell in our grid. The outer loop goes through each column, x coordinate. The inner loop goes through each row, y coordinate, within that column. For each cell, it creates a new ColorRect node with these properties. Size is set to our cell size constant, 10 by 10 pixels in our case. Position is calculated based on the cell's grid coordinates multiplied by cell size constant. Color is black for wall cells, true in our grid, or white for empty cells, false in our grid. Each ColorRect is then added as a child of the Cave Generator node, effectively drawing our cave structure on the screen. Now that we have all our code ready, we can add the function calls to the Godot.ready function. The randomized function is Godot's built-in random number generator. The initialize grid function creates a 2D array filled with random walls and floors. The generate cave function applies cellular automata rules to create cave-like structures. And lastly, the draw cave function visualizes the cave using ColorRect nodes. Now, run the scene and you should see a procedurally generated cave-like structure. This technique can be easily modified to create different types of terrain by adjusting the initial random fill percentage, the number of iterations, or the rules for cellular automata. You could also add more colors to represent different types of terrain, or use this as a base for generating more complex game levels. If you enjoyed this video and want to see more bite-sized Godot tutorials, don't forget to smash that like button and subscribe to the channel. It really helps us out and lets us know what kind of content you want to see more of. Got any questions or ideas for future tutorials? Drop them in the comments below. Until next time, happy game developing.